Imagine it's 2 in the morning. The main application database is throwing just massive latency errors, and everything is grinding to a halt.
Oh, the absolute worst nightmare for an IT team.
Right, so you dig into the architecture, you find the corrupted table causing the bottleneck, you deploy the fix, and you drop a quick message in the overnight team channel. You just type, "Table dropped, migrating data now."
Uh-oh. I see where this is going.
Yeah, you meant, of course, that you dropped the corrupted table. But the overnight shift lead reads it, completely panics, assumes you just dropped the entire production database, and immediately triggers a massive, highly disruptive disaster recovery protocol.
And just like that, a perfect technical fix transforms into like a massive operational catastrophe, not because the code was wrong or your diagnosis was flawed, but because the message itself lacked context.
Exactly. The architecture of the communication was fundamentally broken, and that is the reality we live in. We spend years learning how to, configure complex networks, secure firewalls, or administer these incredibly precise healthcare protocols.
We treat those physical and digital systems as logical, right?
Right.
Governed by strict rules.
Right, but the moment we have to interface with human beings, we treat it as an afterthought. We just assume the data will speak for itself.
Which is exactly the core problem we're dissecting today. I
Hmm.
mean, Einstein supposedly said, if you can't describe it simply, you don't understand it well enough.
That's a great quote.
It really is.
Hmm.
Because if you have the ultimate patch to a zero-day vulnerability or a life-saving procedural update for a hospital floor, but you cannot successfully transmit that idea into the minds of the people who need to authorize it, your technical brilliance is functionally useless.
Ideas that can't be communicated simply do not survive. So, welcome to your deep dive into week 1 of IT 226, Communications for STEM Professions. We know exactly who is listening right now.
Yeah, you're probably squeezing this audio into a commute.
Or catching up between shifts at a hospital, or playing it late at night after the kids and the dogs are finally asleep. You don't have time for vague platitudes about teamwork.
You want the bottom line up front.
Exactly. You look for the error log, you find the problem, and you execute the fix. Ambiguity is your enemy. You've got that analytical mindset. You want structure and actionable instructions.
So we are going to treat communication as a hard system today. We're going to break down the mechanics of why technical minds often fail to get their ideas adopted.
And we're going to give you the strategic roadmap for crushing your week 1 assignments. Because these aren't just busy work, right? They're designed to stress test your communication protocols.
Absolutely. So let's start with the foundation. In your sources this week, there's a breakdown of 3 distinct communication styles: technical, professional, and academic.
Yeah, and at first glance, I was really tempted to just call this a toolkit. You grab the hammer for one job, the screwdriver for another.
Right, that's how most people see it.
But reading deeper into the materials, they don't seem like mere tools. They operate more like entirely different operating systems for how information is processed by the receiver's brain. Okay, let's unpack this.
That is actually a much more accurate way to frame it. An operating system dictates how data is interpreted, right?
Yeah.
So let's look at the technical style first. Its OS prioritizes absolute, unambiguous replication.
So like step-by-step manual.
Exactly. Standard operating procedures, incident response reports, API documentation. The goal is stripping away all subjectivity. 10 different engineers reading the document should execute the exact same physical action without deviation.
So technical is the manual to fix the server. Pure, cold utility, which is totally different from the professional style.
Oh, completely. If technical is the code running the local machine, professional is the network protocol connecting multiple machines across the business.
It's your emails, your stakeholder updates, your project pitches. It relies heavily on relationship management and, well, persuasion.
Because the objective shifts entirely. You aren't just trying to get someone to replicate a step anymore. You're trying to coordinate action across different departments that, honestly, usually have competing priorities.
Right. So if you use a technical operating system, cold and stripped of context, to send a professional request to the finance department asking for, like, a massive budget approval.
Your request will be denied.
Yeah.
100%. Finance doesn't need to know the granular mechanics of the new server. They need to know why the investment matters to the bottom line. You have to translate the technical reality into their operational language.
Okay, that makes sense. And then we have the academic style, which, honestly, I push back on this bit. I struggle to place it in the day-to-day grind.
How so?
Well, it's highly analytical, it's heavily evidence-based, it's used primarily for research papers. If I'm dealing with a chaotic hospital floor or mitigating an active cyber breach, I am not writing a peer-reviewed journal article. It feels a little disconnected from a real STEM career.
I completely understand that skepticism. It does feel like something safely quarantined inside a university library. But let's look at the underlying cognitive mechanism of the academic style.
Okay, I'm listening.
It's structured argumentation built on empirical data. You might not be writing a formal journal article, but when you have to convince an executive board to completely overhaul your legacy IT infrastructure,
Oh, I see.
yeah, you are pulling directly from that academic operating system. You can't just say the old system is bad. You have to synthesize historical performance data, cite industry precedents, and construct a bulletproof, evidence-based argument that withstands executive scrutiny.
Okay, you sold me. It's the training ground for high-level critical thinking. It forces you to mathematically prove why a solution works rather than just confidently stating that it does.
Exactly. Which ties directly into the strategy for the 1-1 activity this week.
Right, so for the 1-1 activity, the assignment asks you to define these three styles, provide at least two specific examples for each, and then answer this really highly debated question: is communication the most important skill for a STEM professional?
The strategy here is crucial. The goal is not to just regurgitate textbook definitions. If you simply copy and paste what we just discussed, you're bypassing the actual cognitive exercise.
Yeah, the prompt specifically says in your own words.
You have to define these styles based on how you personally distinguish them in your specific field.
And regarding that final question ranking communication against all other hard technical skills, you don't have to pretend to be a cheerleader for communication to get a good grade. Right.
Not at all. There is no correct answer.
Yeah, if you genuinely believe that writing flawless Python code or executing perfect surgical techniques is like 10 times more important than writing a good email, you can absolutely make that argument. You can have a highly negative view of communication and still get an exceeds expectations if you argue it well.
Because the assignment is testing your academic operating system. It's testing your ability to construct a logical, evidence-based defense of your position.
Right. Okay, so moving beyond the styles. If styles are the operating systems, the materials say the modes of communication represent the hardware, like how we actually deliver the signal.
Yes, the 5 modes: linguistic, oral, visual, spatial, and gestural.
Linguistic and oral are pretty straightforward. Precise text and clear speech. Visual and spatial also register immediately for technical professionals, I think.
Oh, for sure. A network topology map or a spatial diagram of a server rack can instantly solve a problem that would take 20 pages of dense text to explain.
They bypass that whole bottleneck of sequential language. You look at a complex system map, your brain processes the relationship spatially and simultaneously. But then, and I have to push back here too, I hit gestural on this list.
And you're skeptical.
Very. I get gestures if you're an orchestra conductor, but we're talking about cybersecurity and IT and healthcare. I'm just picturing someone trying to secure a firewall by aggressively waving their hands around. How does pointing help?
In a quiet, controlled office, maybe it doesn't. But let's place you in a massive, humming data center with rows of blade servers where the ambient noise is literally deafening.
Oh.
Or place yourself on a busy trauma ward or an active construction site.
Mm-hmm.
The linguistic and oral modes are completely neutralized by the environment. You literally can't hear each other.
That's a great point.
In those moments, gestural communication, pointing out a specific physical port, modeling the shape of a connector with your hands, using physical cues to demonstrate safety zones, that becomes your primary feel-safe.
It functions as a redundancy system. If the audio channel fails, the visual and physical channels automatically take over.
And it's also a matter of cognitive accessibility. When you present complex data to a room full of stakeholders, they all possess different cognitive processing strengths.
Mm-hmm.
Layering your modes, so speaking clearly while displaying a spatial diagram and physically directing attention to key metrics on the screen, that ensures the signal reaches the receiver, regardless of whether they're a visual, oral, or kinesthetic learner.
Which requires a level of deep audience awareness that STEM education hasn't traditionally prioritized at all. We're usually taught to focus obsessively on the data and just assume the audience will catch up.
Which is why the concept of STEAM is gaining so much traction.
Yeah, here's where it gets really interesting. Adding the arts into science, technology, engineering, and math. The sources mention research on a STEAM summer school in Malta where they literally put science communicators through theater and comedy training.
The mechanism behind that training is actually brilliant. Theater and comedy are hyper-focused on real-time audience feedback loops.
Right, because in a sterile lab, your data doesn't react to your tone of voice.
Exactly. But on a stage, if you lose the audience's attention or confuse them, the feedback is immediate, it's visceral, it's impossible to ignore. By forcing highly technical professionals into those theatrical environments, they physically train the neural pathways associated with empathy, timing, and reading a room.
They have to constantly ask themselves, is my message actually landing? Which leads to a really powerful cognitive strategy highlighted in an article by the National Science Teaching Association. They talk about flipping the approach for STEM communication.
Right, because the traditional academic model is so deeply ingrained in us. You establish the extensive background, you detail the meticulous methodology, you lay out the raw data, and then finally, you reveal the grand conclusion.
It's a chronological journey, which is fantastic if you have a captive audience of academic peers who care about the journey.
But if you're speaking to a client or a hospital administrator or a busy executive,
They do not care about your journey. They care about the destination. The article argues we have to put the bottom line up front. Start with the core takeaway, the operational impact, the immediate solution.
you have to earn their attention by proving the value of the interaction in the first 10 seconds. Then, if they want the underlying methodology, you have it ready to deploy.
But, even with the best operating systems, the most layered modes, and the sharpest bottom line strategy, human error happens. We misinterpret signals. The data gets corrupted in transit.
Because communication doesn't happen in a sterile vacuum. It happens in messy environments, heavily influenced by external and internal barriers. The sources highlight three primary causes of miscommunication: environment, emotion, and culture.
We touched on environment with the noisy server room. Culture is another massive, often invisible variable. The baseline for respect, urgency, or authority shifts radically across different global teams.
The cultural example of an empty plate of food illustrates this perfectly.
Oh, yeah, I loved that example.
Right. In one culture, finishing your meal signals deep respect for the chef. In another, an empty plate signals that you are underfed and you're demanding more. If you don't understand the cultural protocol, the exact same physical data point yields two wildly conflicting interpretations.
But the barrier that disrupts technical teams the most, I think, because it's so hard to objectively diagnose, is emotion. Emotion fundamentally alters cognitive processing.
It really does.
Let's dissect the Kate and Raza story from the course materials, because it models this breakdown perfectly. Kate finishes a major report and hands it off to Raza. The next day, Kate sees Raza in the break room. Raza refuses to make eye contact, displays closed-off body language, and just walks out without saying a word.
And Kate's brain immediately jumps to threat detection.
Exactly. Raza hates the report. I failed. My professional reputation is in jeopardy.
Kate interpreted Raza's physical data, the lack of eye contact, the swift exit, as a direct, critical response to her report. But the reality was entirely disconnected from the workplace.
Raza was just having a bad day, right?
Yes. Raza was dealing with a significant personal issue. Her emotional state was heavily taxed, and her brain had shifted resources away from social diplomacy and toward internal coping. Her body language was simply a physical manifestation of internal stress.
The report was actually fine, but the miscommunication caused a massive spike in unnecessary anxiety and damaged trust. So, practically speaking, when our listeners inevitably encounter these exact barriers this week at work, what's the protocol for resolving them?
The strategies depend entirely on diagnosing the type of barrier. The sources suggest a binary approach: act fast or act slow.
Okay, so when do we act fast?
If the barrier is informational, say you receive technical instructions that are ambiguous or lack context, you must act fast. Don't let the ambiguity fester. Ask for clarity immediately before a small misunderstanding compounds into a systemic failure.
So act fast to clarify data, but act slow to manage emotion.
Exactly. If you're in a meeting and a stakeholder is visibly agitated, or you receive a highly aggressive, emotionally charged email acting fast, usually result in a defensive, escalated response.
You just end up matching their energy.
Right. You have to artificially insert a delay, give their nervous system time to stand down, and give your own brain time to process the actual intent behind the message, rather than just reacting to the hostility of the tone.
And if you were the one who caused the miscommunication, if you sent the ambiguous email or let your bad day bleed into your tone during a shift change, the protocol is a sincere apology, but a real one, not just, hey, sorry about that.
You have to explain why the miscommunication happened and acknowledge the specific operational impact it had on the other person. You have to actively repair the trust architecture.
Which brings us perfectly to the week 1 to 2 discussion. This entire dynamic is the core engine of that assignment. It's not just an icebreaker, it is a diagnostic exercise.
The strategy here is to introduce yourself, your major fun facts, share your personal baseline regarding writing, and then dissect a real moment from your own professional or personal life where communication fundamentally broke down.
You essentially have to lay out a scenario similar to Kate and Raza. And then, the critical part. Your peers are going to analyze your scenario and recommend how those specific tools act fast, act slow, layering different modes could have averted the crisis.
It's a collaborative postmortem on human error.
I love that framing.
Yeah.
But, executing these strategies in the real world requires a certain level of internal stability. If you are constantly second-guessing your own expertise, your communication naturally becomes hesitant, defensive, and ineffective.
That connects to a fascinating study in the Journal of Microbiology and Biology Education about the theory of planned behavior. Researchers looked at undergraduate STEM students to figure out what actually motivates them to share their knowledge publicly.
And they identified 2 critical internal mechanisms, right? Science identity and science self-efficacy.
Yes.
Yeah.
Science identity is the psychological shift from feeling like an imposter looking in saying, I'm just a student taking an IT class, to internalizing the role and saying, I'm an IT professional.
And science self-efficacy is the concrete belief in your actual capacity to execute the work. It's not just knowing the theory, it's trusting that your hands can configure the router or your brain can write the script.
And the study shows that when you build both of those internal traits, they physically rewire your motivation. You stop viewing communication as a risky vulnerability where you might be exposed as a fraud, and you start viewing it as a necessary, powerful tool to advance your field.
But building that self-efficacy requires actually going through the cognitive struggle of doing the work, which brings us to a critical pivot regarding the tools students use today, specifically generative AI.
We really need to talk about the philosophy of learning here because it directly impacts your self-efficacy.
Let's lay out the do's and don'ts of Gen AI for this course, because we have access to tools that can instantly bypass that cognitive struggle now.
Right, so for the DOs, using a tool like Grammarly to catch spelling and syntax errors, or using an AI to brainstorm broad concepts when you're staring at a blank page, or to clarify a concept, that's generally fine. Just always cite your AI usage. It's like using a calculator for complex division. It aids the process.
But for the don'ts, when you use generative AI to actually author your thoughts, you are short-circuiting the neural pathways required to build self-efficacy. Writing isn't just recording what you think. It is the active process of figuring out what you think.
If an algorithm writes your reflection on a personal miscommunication, you didn't learn how to process that event. You outsourced your critical thinking.
And when you're in a high-stakes meeting and you have to defend a technical decision on your feet, the AI won't be there to feed you lines. Your self-efficacy will just collapse because you never actually built the internal architecture to support your ideas.
Furthermore, from a strictly academic and professional standpoint, these models frequently hallucinate facts. They invent citations and fabricate data.
Yeah. You cannot treat it as a scholarly source.
Absolutely not. And if you input proprietary course materials or sensitive workplace data into them, you aren't just compromising your learning. You're introducing severe structural vulnerabilities into your work and violating intellectual property standards.
So the hard rule for this course provides absolute clarity. AI is strictly off limits for generating text for all discussion questions and the 1-1 activity. These assignments are designed to capture your authentic, messy human cognitive process. It's about building your specific, authoritative voice, not outputting an aggregate average of the internet.
We've covered a lot of ground today. The operating systems of the 3 styles, the hardware of the 5 modes, the psychology of emotional barriers, and the internal mechanics of building your professional identity.
So what does this all mean? Let's synthesize this into your step-by-step roadmap for week 1. First, read the course scenario and the rubrics. Treat them like the technical documentation for a new system deployment. They outline the exact parameters for success.
Next, tackle the 1-1 activity. Remember, 500 words minimum, double-spaced. The objective is to define technical, professional, and academic styles in your own words. Bring your own examples and construct a highly logical argument defending your view on the importance of communication in STEM.
Then complete discussion 1 to 2. Treat this as a high-stakes postmortem intro, writing beliefs, your miscommunication story, and then 2 substantive peer responses recommending solutions. And remember, discussions are worth 50 points and cannot be made up late.
And finally, submit original work. No self-plagiarism, no verbatim AI text. And if life gets in the way, reach out to your advisor.
As you log off and transition back to whatever is next, your shift, your family, your studies, we want to leave you with a concept from author Ann Whitaker that was mentioned in the sources. She frames every message you send as a postcard to the future.
It is a really profound way to view data transmission. Because a message doesn't cease to exist once it leaves your outbox or your mouth. It lands in someone else's cognitive space. It's stored, remembered, and reshaped in their memory.
It ripples forward through time. It influences future decisions, shapes your professional relationships, and dictates whether your technical brilliance is ever fully realized by the people around you.
The physical systems you build in the server room or the hospital might last a few years before they're obsolete and replaced. But the communication architecture you build with your team compounds over an entire career.
So, when you open your laptop later tonight and start drafting that assignment, or when you send that next late night update to your shift lead, what kind of legacy is your postcard leaving behind?